in presenting activity 1 with you. So again, katulad sa lecture kanina, available na rin sa inyong class notebook yung ating class calendar. Okay? So here, we will have the following due dates. Okay? Na makikita ninyo. Okay? So there is a 1 week, so again, katulad dun sa homeworks nyo kanina pinaliwanag ko, for the first 2 sets of submissions, meron dalawang set of deadlines or meron dalawang set of due dates. Okay? So, yung first set is yung May 15 tsaka May 22 na deadline, okay, which is the due date for activity reports assigned from week 1 to week 5. Okay. Next is ito, yung second set of deadline, yung June 5 tsaka June 12. Okay. And I know June 12 is a holiday, pero since deadline lang naman siya, then yan na, yun na lang na June 12 is just a deadline. Okay. And then yung last deadline natin is June 23. Okay, which is the final due date for activity reports for submitted assigned from week 9 to week 11. Okay, so ayun, those are the deadlines that you are to meet for your activities. Now, as I also said earlier, okay, it is possible na mag-extend tayo ng deadlines for activities ninyo, okay? But siguro siya, case to case basis siya. Okay? So you can ask for an extension and then tingnan natin if may bibigay natin siya. But the maximum date that I can give for an extension is itong June 23 na to. Okay? Yan lang yung maximum date na pwedeng maibigay natin. So, by June 23, dapat lahat ng homeworks, lahat ng activities have been turned in. Okay? Beyond June 23, wala tayong tatanggapin na activity reports. Naiintindihan ba? Okay. So, ayun. Now, then makikita nyo dito, ang magiging schedule ng inyong final skills assessment would be June 28 to June 30. Okay? So, yun yung natin. Tapos, July 3 is the final grade verification tsaka online submission of final grades. Okay. By the way, naalala ko pala, at hindi ko nabanggit ito with the lecture class kanina, no? Pero ganun din yung date kasi, pareho lang. Kasi Monday and Thursday class yung Monday-Thursday class yung hatian. So since both of your lecture classes follow na Monday, tapos Thursday yung lab natin, pareho to ng date. We have make-up asynchronous classes for this term. Okay? Dahil yata to dun sa sa extension na or dahil sa ang tawag ito, sa parang nausod kasi yung opening ng classes natin by 2 weeks. So yung makeup asynchronous class na to is prescribed by the term calendar, by the university calendar for term 3. So yung for Monday Thursday classes, ang ating ang date ng asynchronous makeup asynchronous class natin is Sunday, May 23. Okay. Now, this is an asynchronous class. So which means at that time magkakaroon tayo ng AL meeting. Okay, during that day. Okay. And I'm 100% pretty sure, okay, I'm 100% pretty sure na hindi naman natin kailangan mag-live mag-live class nito during that time. Okay? So more or less baka hindi tayo talaga magganito asynchronous class during this time or asynchronous magklase during this time. Okay. But I'll still host an AL meeting for this one. Just so we can make it as a consultation day for all of us. Okay? So, meron din 'yan sa pag tiningnan niyo yung sa niyo sa sa lecture class ninyo, meron din siyang ganyan. At Sunday, May 23 din siya. Okay? So, may questions ba regarding this one? Okay, so mukhang wala. So, let's proceed with your activity 1. Okay? So, activity 1 is about generation of discrete time signals. Okay, so in this activity, we will demonstrate how MATLAB doon naman tayo. Okay. We will demonstrate how MATLAB can be used in the generation of discrete time signal. So when we say generation, that is we define the sample values and store it in an array. Okay? So, yan yung gagawin natin with when we say generation. Okay? So, at the end of this activity, the student should be able to create MATLAB functions that generate elementary discrete time signals and generate and plot arbitrary discrete time signals using MATLAB commands. Okay? So, this addresses yung ating 1, 2, and 6 course learning outcomes natin, which is number 1, use terms, concepts, and principles in and around the discussions on the signal processing. Okay, analyze discrete time signals and systems in time domain, and use computing software as a tool in the analysis and processing of signals, as well as in the analysis and design of signal processing systems. So, yun ang ina-address ng activity na to. Okay? So, you needed a workstation installed with MATLAB and signal processing toolbox. Okay? And symbolic math toolbox. Okay? So, yun. So, a discrete time signal can be interpreted as a sequence of values represented as a vector. Now, this vector can be either row or a column vector. Okay? Each value is indexed to pinpoint their location in the vector. So, itong index na to, okay, is the n. Okay? So, if you've been listening in the lecture kanina, okay? So, yung pinag-usapan natin at length yung meaning nung n as an independent variable for xn. Okay, kung ano yung meaning nung n. So, binigyan natin ng 3 pangalan yan. Ano nga ulit yung ipinangalan natin sa n na yan? Anyone?
Index po.
We have n as number 1.
Sample number po, sir.
So, we can name it as number 1, sample number. Okay? Pwede siya pangalan as a sample number. Number 2, we can call it also as the time variable. Okay, and number 3, the index. Okay, see the index of your array. Or, more specifically, it can be called as your time index. Okay? So, very good. Now, so as we have stated earlier, ito yung magiging form ng xn ninyo, wherein we will use an arrow in order for us to indicate which sample is at n equals 0 or is at 0 index sample. Okay? So the arrow pointing upward indicates the value above it is the value at index 0. MATLAB can easily and neatly represent the discrete-time signals because vectors and matrices are native data types to it. Okay, so madaling mag-represent ng mga signals in this way, in this manner because native data type ang array sa MATLAB. A problem, however, is that MATLAB can only represent finite duration signals. Okay? So, and that it may need additional information in terms of indexing since MATLAB would always represent the first element with index 1. So, ito yung natandaan nyo pa. Whenever you have an array with MATLAB, okay, whenever you have an array with MATLAB, yung indexing ng array sa MATLAB, it starts at 1. Okay? And it can never be negative. So, for example, if you have a vector x or if you have an array x, tapos meron kayong mga numbers dyan sa array na yan. Okay? Always, this is for MATLAB, always the first element, okay, occupies the index 1. Okay, it occupies the index 1 for MATLAB. Okay? So that is why kanina ang suggestion natin is that we create a separate vector para sa inyong time index, para sa inyong n, okay? So nakita niyo nga kanina na we try this with, for example, x equals 77, 55. Nakalimutan ko yung example natin kanina. Ito lang. We have n from negative 6 to positive 6, which is the separate index na separate time index that we have. Okay? And then we have x equals 2 times n squared, okay, plus 5. So yan. So you now have your n, okay, and then you now have your x. Okay? So dito sa x lang titingnan natin ha. Let's just look at x. Hindi kayo makakita dyan. Pag tinignan nyo dyan x of 0, mag-e-error yan. Okay? It would return an error. Okay? So, why would it return an error? Basically because, array indices must be positive integers or logical values. Okay? So, in this case, hindi natin pwedeng gamitin yung 0 or negative numbers as an index dun sa ating array when we are talking in or when we are doing it in MATLAB. Okay? So that is why what I suggested was to use logical indexing. Okay? So ang gagawin natin is that we will index x with a logical expression testing whether n equals 0. So ang hahanapin ng MATLAB is that it will test this logical statement. So hahanapin niya ngayon sa n, okay? It would find among these values, okay? It would find among these values yung index or yung values for which n is equal to 0. Okay? Ito kasi magiging result nitong yung n equals 0, yung test na yan. Yan yung magiging result niya. Okay? So, ito yung kino-compare ng statement nyo, yung n or yung value ng n sa 0. Okay. Isa-isa niya yung n niyo. Okay, which is wait lang. So, isa-isa niya i-compare yan sa 0. So, is negative 6 equal to 0? So, 0 means no. Okay, so is negative 6 equal to 0? No. Negative 5 equal to 0? No. Negative 4 equal to 0? No. And so on. Ngayon, pagdating dito, is this 0 equal to 0? Yes, ang magiging sagot niya. Okay? So yun yung magiging result ngayon ng logical nung logical statement na to is this array. Okay? Now, pag ginamit niyo yan as an index, such as in this one, okay? Pag ginamit niyo yan as an index, as in that case, okay? It means, hahanapin niya yung 1 dyan. Okay? Hahanapin niya kung alin yung nag-1 dun sa logical array na yan. Okay? Tapos, gagamitin niya yon, okay? Gagamitin niya yon in order to index your x. Now, since ang nag-1 dito is 1, 2, 3, 4, 5, 6, 7 element. Okay, nung logical array natin. Then, i-index niya si x for its 7th element. Okay? So, kung ito yung x natin, the 7th element to there is 1, 2, 3, 4, 5, 6, 7. Okay? Or yung x7, that's the proper kasi index para sa MATLAB, that gives you 5. Okay? Which is the same as x of n equal to 0, which is also 5. Okay? Naintindihan ba yun? So, if you are to use MATLAB, pagka kayo ng mga ganito, kayo ng mga arrays at saka ng okay. You have to recognize kung ano yung limitation ng tool ninyo when it comes to some things, like in this case indexing. Okay? So in the case of indexing, sa theory, okay, or sa paper, pwede tayong mag-index ng, for example, -6, -5, -4, okay yun. Pero pagdating dito sa MATLAB, hindi kasi pwede yun. Okay? Even 0, hindi natin pwedeng gamitin to index. Okay? So, we'll have to do some workaround, okay, regarding that. Kailangan magkaroon tayo ngayon ng workaround. And that workaround is by using logical indexing. Okay? Maliwanag? So, use logical indexing instead of straight up indexing to overcome MATLAB's restriction for array indices. Okay? So, ayun. So, now, this is the part wherein we will have to talk about the main lesson that we will have to learn from this activity. So, generation of elementary discrete-time signals. So, the elementary discrete-time signals are the most fundamental signals used in analysis of larger, more complex signals and systems. By the way, as I was saying in the lecture bago tayo matapos kanina, that this is actually a continuation of what we have been discussing there. Okay, ito yung para magiging continuation niya. So, it's a lucky coincidence na nagpang-abot silang dalawa on the same day. So, kaya medyo convenient para sa atin kasi medyo parang isang discussion tuloy yung na-target ko. Okay? Simula pa kayo ng umaga hanggang ngayon. Okay. So, what are these elementary discrete time signals? Okay? So, kanina sabi ko 5 to. So, these elementary discrete time signals include the unit sample or unit impulse sequence. So, we have number 1, unit sample or unit impulse sequence. Okay? May symbol yan na delta n. Okay? Number 2 is the unit step sequence. We'll use the symbol UN for that. Okay? Number 3, we'll have the exponential sequence. And your exponential sequence can either be real valued or complex valued. Okay. Then number 4, we have sinusoidal sequence. Okay. And yung number 5 kasi actually, yung random sequence, hindi naman siya considered na elementary. Okay? This is not, hindi siya basically or technically considered as an elementary discrete time signal. But, bagka pa dyan yun. But we will include the random sequence in how they can be generated in this context. So, i-include natin siya in the discussion kasi importante sa atin dahil importante sa atin that we have to know how to generate random sequences. Okay? Basically because some of the situations that we will have to deal with are those situations where random signals or random sequences may be involved. Like for example, mag-a-analyze tayo ng sequence or mag-a-analyze tayo ng signals na merong na corrupted by noise. Okay? So, yung noise, pag gusto natin siyang i-integrate or isama sa analysis, okay? Kung gusto natin siyang isama sa analysis, we will have to be able to generate this noise, okay? And that noise can be modeled or can be generated by generating a random sequence. Okay? Naintindihan ba? So, random sequence. So, technically, ang random sequence is not an elementary discrete time signal. Okay? But still, isasama natin siya dito sa i-generate natin. Okay, so let's start. So, the unit sample sequence delta n, okay, is defined as 1 when n is equal to 0. Okay? And 0 siya when n is not equal to 0. Okay? Tignan niyo yung selection nyo dyan. Ito. Yan. Ano yung panlima nito? Sali lang. Bakit po? Ramp. Hindi ko pala naisama yung ramp dito. Yung pala yung nawawala sa activity niyo yung ramp. Okay. 5. Okay. Sige. Kaya pala 5 to. Okay. So, ayun. Ito yung itsura ng unit sample sequence niyo. Okay. So, the definition of the unit sample sequence is 1 for n equals 0 and 0 siya for n not equal to 0. Okay. So, it's a signal that is 0 everywhere except at n equals 0 where its value is 1 or unity. So, kapag rinap nyo ang unit sample sequence, ito yung itsura niya. Okay. So, it is 0. Okay. It is 0 at these indices. So, yung kapag yung indices nyo is not equal to 0, then 0 yung value ng signal niyo. Whereas, pag ang index niyo ay 0, okay, ang value ng signal niyo ay 1. So, that's delta n. Okay? Now, it is possible to produce what we call a shifted version. Okay? A shifted version of delta n. Okay? So, sa notation, or sa functional notation, ang shifted version ng delta n is denoted as delta n minus k. Okay? So, ang definition ng delta n minus k nyo ngayon is that delta n minus k is equal to 1 when n is equal to k. Okay? And 0 siya when n is not equal to k. So, which means ito, depende lang sa value ng k, masishift siya ng pwesto. Okay? Kung ano yung value ng k, dun mapupunta yung 1 na sample. Okay, naintindihan ba? Okay. So, gawa na nga ako ng copy nito dyan. Para doon na lang ako mag-ano. Copy. Paste. Diretso mag-sync ngayon. Ayan. So, sige. So this is the the unshifted version, and this is the shifted version. Okay. Now, in this in MATLAB, we can actually generate those kind of signal in many ways. Okay? So, marami tayong pwedeng gawin para makapag-generate ng ganyan signal. Okay. One suggestion that I can give you is the use of the function zeros and ones. Okay? Yung paggamit ng function na zeros and ones. Pero in this case, since isa lang naman yung 1 nyo dito, hindi nyo kailangan gamitin ng function na 1 na to. Kasi isa lang naman yung 1 na kakailanganin natin eh. Okay? Pero marami tayong zeros na kailangan. So instead of actually repeatedly writing zeros, okay, especially kung ang array na gusto nyo i-generate medyo mahaba-haba. Okay, then you can use zeros to generate multiple number of zero elements. Okay? So, in MATLAB, the function zeros generates a matrix of m by n matrix whose elements are all zeros. Okay. Thus, the command 0, 1, n, okay, zeros 1, n generates a row vector of n zeros. Okay, which can be used to generate delta n over a finite interval. So, for example, pag ginawa niyo yung command na lagyan niyo ng comma to okay, para lang nasa-separate niyo yung mga elements. Mukhang kailangan kong i-edit tong edit tong manual na to, parang ang tagal ko na sinuot nito pala. Okay, so you have x equals 1 tas comma zeros 110. It will generate a row vector x of length 11 na ito yung itsura. Okay? While the command x zeros 15 tapos 1 tapos zeros 15 ulit generates the same length vector but puts the element 1 in the middle. So, magiging ganito siya. Okay? So, makikita nyo ngayon dito sa dalawang examples na to on how zeros can actually be used to generate delta n at saka delta n minus k. Okay? So, pwede kayo magkaroon ng idea on how to do this. Okay? Using the zeros function. Okay? So that's one way. Now, again, it can represent a delayed or advanced version. It can represent a shifted version, okay? Or the base signal itself, okay? Depending on the index assignment of the first and the last element. Kasi wala naman tayong nilalagay na na index or na time index sa dalawang yan. So therefore, we don't have any idea on kung siya ba ay shifted version or whatever. Okay? You can just simply add that information in a separate command. Okay? So another way of generating your delta n function is the logical relation of this one. Okay? Yung logical test na n equals 0. Okay? So, in fact, kung ang gusto nyong gawin ay mag-generate ng ng logical relationship ng delta n, okay? You can just simply create a time index n o time vector n, okay? Pwede kayo mag-generate ng vector para sa n. Okay? And then gamitin nyo to in order to create a logical array. Okay, katulad nung ginawa ko dito kanina. Nag-generate tayo ng n. So you have n this one. Okay. Tapos pwede kayong pwede niyo i-generate ngayon yung delta n. Lagyan natin yung u delta. Lagyan ko na ng 1 kasi may u delta function ako dito eh. So baka mag-ano. So u delta, okay. Equal sa n double equal to 0. Okay? So which means na gagawa to ng logical array, katulad ng nakita nyo kanina. Gagawa ng logical array. Tapos i-assign niyo yun sa u delta 1, na variable. Okay? So yung magiging itsura ng u delta 1 na variable niyo is this one. So makikita niyo dito that this is a unit sample sequence from -6 to +6. So again, ang definition is 1 siya. Okay? This is 1. Okay? For n equals 0. Okay? And 0 siya for n not equal to 0. For example, pwede nyo siyang i-test. U delta 1, n equal to 0. Ang value niyan ay 1. Okay? O kaya, gawin natin, ilagay na siya sa negative, for example, 4. So you are evaluating u delta negative 4 dito. Okay? Mali. Dapat pala ito. Yan. Okay? So 0 siya. Okay? Naintindihan ba? Wala bang questions dyan? Okay, kung gusto niyo yung shifted version, at gawin nating negative 10 to. At, wait lang pala, bago pala ipapasok sa shifted version, no? Mapapansin nyo, yung results niyan, nakalagay, logical array. Okay, you will notice that ang nakalagay sa kanya is logical array. Okay? Now, that might not be so harmless. Okay? Kaya lang just to be safe lang. Okay? Just to be safe lang. Kasi ang problema nito is that iba ang treatment ito kapag ginamit niyo siya sa computation. Halimbawa, gagamitin niyo tong u delta for some mathematical computations along with other with other numbers, okay, which may be, for example, double, okay, or double precision. Baka lang magka-problema kasi kayo kapag nagkaroon ng typecasting or nag-perform ng typecasting si MATLAB. Okay? So para maiwasan niyo 'yon, unahan niyo na si MATLAB. That is, kayo na mismo yung mag-typecast sa kanya. Okay? I-convert nyo na kagad yung results ng logical array into a double precision number. So that is done by the double function. So imbis ngayon, ito kasi magiging logical array ito. Okay? But putting it inside the double function converts ito into a double precision floating point number array. Okay, instead of a logical array. So makikita niyo 'yan. Walang lalabas na logical array. Kasi ngayon, itong mga numbers na 'to, all of these are double precision numbers na. Makikita niyo 'yan dito sa workspace. Yan, double na siya. Kung wala yung double function na 'yon, simply we will have this Okay. Makita nyo, logical yan. Okay? So sabi ko nga baka magka-problema kayo with computations with regards to that. So gawin niyo na kayo na mag-typecast. Okay? Kayo na mag-typecast into double precision number. So ayan, double na siya. Naintindihan 'yon? Excuse. Ngayon, kung gusto yung shifted siya, okay? For example, dito, pag naglagay kayo ng, for example, -4, okay? So, ano mangyayari? Ilalagay ngayon ni function niyo or nitong command niyo, itong expression na to, yung sample natin na non-zero, okay? Dun sa n equals -4. So kung -10 to +10 yung n natin, these are the samples at -10, -9, -8, -7, -6, -5, -4. Okay? -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Naintindihan? Okay? O kaya, kung yan ay nasa +6, okay? Kung ang test nyo is at n equals 6, okay? Then ilalagay nyo yan kung saan +6 yung value nung index n ninyo. So these are the samples at n equals -10, n equals -9, -8, -7, -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6. Okay? 7, 8, 9, 10. Maliwanag yun? Okay, so what I presented here are two ways of generating your unit sample sequence. Okay? So I presented two ways of generating your unit sample sequence. Number 1 is yung paggamit ng zeros. Okay? And yung number 2 is yung paggamit ng logical test na to. Okay? The use of the logical test for that. Okay? So those two are actually further reinforced in this procedure. So ito at saka ito. Kaya lang dito kasi ginawa natin yung procedure na to. Okay, yung second procedure. Dito kasi tina-type pa natin siya, di ba? Tina-type natin siya isa-isa. Okay? Now, instead of actually typing it one by one, okay, o typing it every time na gagamitin natin, then gumawa na tayo ng function for that. Okay, we have already suggested a function code para sa U delta, which requires 3 arguments. Okay? K represents the shift. Okay? It represents the shift. Okay? N1 represents the lower end of your time index vector. Okay? And N2 represents the upper end of the time index vector. So yun yung tatlong arguments nyo dun sa function code natin. Now, this function code returns 2 values or 2 vectors. Yung x contains the so these are the input arguments. And these are the output vectors. Number 1 is x, okay, which returns the values of the unit sample sequence. Okay. Yung n returns the vector or the time index vector. Okay? So ngayon, yung pagkakasunod ng function nyo kasi ito. Ayan siya. Okay? So, pwede kong gamitin yan dito. Okay? In this manner. So, pwede kong kunin yung x at saka yung n, for example. Okay? And then, use u delta function. Okay? Then, yung k ko, delay ko, for example, is 0. Okay? Tapos, the lower end of my vector is -10. The upper end is 10. Okay? So, ayan. Now, my n here is from -10 to +10. So, that's my, ito yun, yung n na to. Okay? That is my um, vector, time index vector. Okay? While yung x ko is the delta function. Or the unit sample sequence. Okay? Which is 1 for n equals 0. For n equals 0. So, -10, -9, -8. Test ko na lang pala. X of n equals 0. So, 1 siya. Okay? So, pwede niyong isulat itong function na to. Okay, so that hindi na rin kayo paulit-ulit na nagta-type ng mga Okay, so para isang tawagan na lang. Okay. And at the same time, later on kasi, in another activity, you'll make use of that of that function. Okay? So that is why I suggest na niyo siya, itago niyo siya para pag gagamitin niyo siya on a future activity, it will come in handy. Okay? So pwede niyong aralin yung skill na nandiyan yung function and naisusulat niyo yung nakakapag-generate kayo ng unit sample sequence using the function. And pwede rin naman na naaalala nyo kung paano siya i-generate by typing it through a command. Katulad nito. Okay? Naintindihan ba yon? Or hindi pala yan? Ito pala. Okay. Katulad nito. Okay. Naintindihan ba? Okay. Sandali lang class kukuha lang ako ng water. Okay. Medyo nag-a-up na naman yung post ni Selvec ko eh. Sandali lang. Okay, nandiyan pa ba kayo? Raise hands nga. Okay, good. So, let us try yung ating isang procedure dito. Okay? So, ito. Let's try yung first yung step 1 ng procedure na to. Okay? So basically may sarili akong copy dito ng so idediretso ko na siya dito sa pagta-type dito. Okay. By the way, bago ko pala makalimutan ito ha. Tawag dito, medyo naalala ko rin kasi. Tawag dito. I was talking to someone, and ang concern kasi is one concern is that nahihirapan siya makagawa ng activity because hindi kinakaya ng computer niya yung MATLAB, whether it's MATLAB online or yung MATLAB na desktop. Okay, and much more pala yung MATLAB na desktop kasi mas resource demanding yun. Okay. Ang sabi ko naman kasi is that pag meron kayong ganung situation, meron kayong same situation na ganun, or kahit wala, okay, kahit na basta try nyo lang din naman. Wala namang masama to collaborate with others on doing your activity. Okay? Kung nasa school naman din tayo kasi, you are allowed to do it in groups. You are allowed to do it in you are allowed to pwede kayo magkumpulan pag nasa school kayo eh. Pag ginagawa niyo yung mga activities niyo, pwede naman kayo magkumpulan. Tapos pwedeng pinapanood niyo yung isa doing the activity, someone explaining what is happening and so on and so forth. Then you can compare codes after that, okay? And then you write a report out of it, okay? So walang problema kung magko-collaborate kayo on that end. Ngayon, ang equivalent niyan sa online, ganito. Pwede naman kayong mag-establish ng parang grupo, and then mag-meeting kayo, conduct a Teams meeting. Tapos someone is demonstrating on how to on what happens when these procedures are done. Okay? May gumagawa ng mga procedure to, tapos pinapakita niya yung results. So yung mga walang MATLAB na at least may chance sila na makita. Hindi man nila nagagawa exactly yung hindi man nila nagagawa excuse me, yung exactly yung procedure, okay? But at least meron silang idea kung ano yung mangyayari dun sa procedure natin. Okay? Then after that, mag-share kayo ng mga results, mag-share kayo ng mga opinion, mag-share kayo ng mga ng mga thoughts about what happened. And then out of it, tsaka kayo gumawa ng sarili niyong report. Okay? Ang sinasabi ko lang naman is that kailangan yung report nyo individualized. Ibig sabihin, nanggaling siya sa sarili nyong thoughts, sa sarili nyong opinion, o sa sarili nyong tingin or perspective dun sa activity. Pero wala naman akong sinabi na bawal kayong ng activity, collaborate on doing an activity. Okay? Naintindihan ba 'yon? Sorry. So pwede yun, no? Pwede niyo tingnan yung ganong setting. Para para at least yung iba yung classmates na at the meantime walang access sa software tools. At least kahit paano, meron siyang chance of makita niya yung results. Okay? in that manner, okay, in that manner, at least kahit paano lahat kayo gumagalaw forward at lahat kayo medyo kahit paano may natutunan kayo. Okay? Although ang i-recommend ko lang din is that later on, pag nagkaroon na kayo ng access or pag nagkaroon na kayo ng chance to access MATLAB, then try things on your own also. Kasi iba pa rin yung muscle memory nung nagta-type ng codes eh. Okay? Iba pa rin yung kayo mismo yung nagta-type ng code kasi nagkaka-idea kayo on especially kung meron kayong kinokopyahan na code like this one. Nagkaka-idea kayo kung bakit yun yung bakit yun yung command at bakit yun yung ginawa for that particular step. Okay? So, diskarte lang pagdating sa mga ganyang mga bagay. It's okay to collaborate with one another, okay? Ang hindi lang kasi okay is yung pare-pareho kayo ng report. Yung pare-pareho nakasolve sa report nyo, which is impossible dahil hindi naman pwedeng pare-pareho kayo ng wording sa nasa isip. Okay? So, ayun, yun yung hindi acceptable doon. Okay. Pero wala namang problema kung pare-pareho kayo ng results. Okay. Pero yung perspective nyo kasi with what the results mean is may be different from others. Okay? Nagkakaintindihan tayo doon? Okay, so I hope na ma-resolve natin yung problema ng iba na wala nahirap ang access sa MATLAB because hindi kaya ng kanilang workstation. Okay? So unti-untiin lang natin. Baka sa susunod meron na kayong chance to have a MATLAB. Edi kayo naman yung mag-demonstrate para kayo yung mag-demonstrate doon sa mga classmates nyo. Para yun nga lang talaga, ang mahirap lang talaga sa collaboration is finding the common time. Yun yung medyo mahirap sa collaboration eh. Kailangan meron kasi kayong common time para magkita-kita at mag-meet over Teams. So, ayun. Kaya, i-plano nyo mabuti. Okay, i-plano nyo mabuti yan. Okay? So, ayun. So, let me do itong procedure na to. Itong, asan na yung yun? Itong step 1 nung procedure na to. Okay? So, pero gagawin ko siya sa editor ha. Then ira-run ko na lang siya dun sa Okay. So, this is procedure generation of unit sample sequence. So, step 1. Once ito is clear, all, close all. Ang N1 daw is from -20 to -1. And X1 is zeros, 1, ibig sabihin 1 row, and yung number of rows, number of columns nung nung zeros natin, vector natin is yung kung ano man yung length nung vector N1. Okay? So N2 equals 0. Okay? Then X2 is 1. Okay? Then N3 is 1 to 20. Okay? Tapos X3 is zeros, 1 length, yan. So ang ginawa basically dito, okay, tuloy natin yung isa pang command. N equals N1, N2, N3. Then X equals X1, X2, X3. Okay, so basically yung ginawa dito para ma-generate niyo yung inyong unit sample sequence, okay, is dinivide niyo yung entire region sa tatlo. Yung unang region is from -20 to -1 in which the value of your x must be 0. Okay, yung pangalawang region yung pangalawang region niya is when n is equal to 0. So when n is equal to 0, your x is equal to 1. Okay? Tapos yung pangatlo is yung region when n is equal to 1 up to 20. So in those region or in those values of n, ang value ng x nyo ay 0 din. Then ginawa nyo, kinoncatenate nyo na lang siya. Okay? Naintindihan ba yon? Yung method na yun? Okay, saglit lang Tuloy natin. Yung next kasi ito is graphing. Okay? Graph. The unit sample sequence. So ito yung mga commands, stem, n, x, field. May makita nyo kung bakit merong field na argument. Title, unit sample sequence, then x label, sample number, that's n, lagay natin yung n, y label, lagay natin signal value, yung signal value, yung y label ng signal value x, wala to sa manual nyo. Dinagdag ko lang grid on, then axis, n1, n, in x minus 0.25 and plus 0.25. Okay. Itong access command na to, this just simply defines the boundary of your graph of your plot. Okay? Ang ibig sabihin nito is ipe-present natin yung axis natin na ang lower x value ito. Kung yung value nito. Tapos ito yung upper x value. Tapos ito yung lower y value. Okay, tapos ito yung upper y value. So yan yung boundaries natin nung ating axis. Okay? So save ko lang to as may pangalan palang procedure. Alay na proc. Ayan. So, ayan. Then, run natin tong section na to. So, this is shift enter. Control enter pala. So, hintayin natin siya. So, wait lang ah. So, ito no, ito yung sinasabi ko sa ano, regarding do sa access command. So, ito yung ano, sa x-axis ninyo, yung unang entry doon, ito. Yung unang entry dito, itong unang entry dito, nung array na yon is, essentially this is an array eh. Itong nakikita nyo to. Yung naka-bracket na yan is essentially an array. Okay? So, itong N1, okay, is the lower x value. Okay? So, ito yung ano, ito yung nandito. Lower x value to. Which is negative 20. Kasi kung titingnan nyo dito, yung pinakaunang, ito yung N eh. So, yung magiging pinakaunang member nito, okay, is yung unang value ng N1, which is negative 20. So, kaya negative 20 siya. Okay? Now, yung upper value niya, yung NN, is the last number of this, or last element of this vector, which is the last number of this vector, which is ito, yung 20. So, magiging positive 20 yung isang dulo niyan. Okay? Tapos, yung kasunod nito, yung min x minus 0.25 is the minimum value of x. Since ang laman lang naman ng x ninyo ay 0 and 1, so the minimum value of x is 0. Then, bawasan mo pa yan ng 0.25. So, yung magiging lower value sa y-axis mo, ito, is yung 0.25. Okay? While the upper value is 1.25 kasi the maximum is 1 plus 0.25. So, 1.25 yung magiging upper value niya. Okay? So, yun yung ano, yun yung ibig sabihin ng access command na to. It just sets yung boundary nung ano mo, nung access mo. So that meron kang decent na ano. Okay? So dito nilagyan natin ng field na ano na argument itong stem para ganito siya. Kasi kung wala yan, halimbawa wala yung field na yan. Ganda yung itsura niya. Yan, ganyan yung itsura niya. Okay? So, that is why, lagyan na siya ng field para medyo may emphasize natin yung mga values. Okay? Maliwanag ba yan? Okay. So, that's for ano, using concatenation and zeros in order to generate your unit sample sequence. Okay? So, ang next natin, okay, step 2 is generating your unit sample sequence using the function delta, u delta. So itong u delta, again, as I have already shown you, naisulat na natin siya as a function. Okay? So naka-save na siya sa isang location na makikita siya ni MATLAB once tinawag ko siya. So ito nga yun. Okay? So ganun yung pagka if you have to use a function, just make sure that the MATLAB will be able to locate where your function is. So the safest way is for you to have it save on a location, tapos i-point niyo yung location na yun dito sa address bar ni MATLAB para lumabas siya dito sa current folder. Okay? Maliwanag ba yan? Okay, so let us do that. Type natin yung commands para sa second sa step 2. Okay, so we have clear all, close all. By the way, the procedure tells you to do the or to type this in the command window. Okay? Pero sabi ko nga sa inyo, sa activity 0 pinakita rin to. Pero doon sa activity 1 niyo sa last course niyo, na pwede nyo namang gawin na yung mga commands na to, ilagay nyo muna sa isang script file. Okay? Pwede nyo ilagay sa isang script file and then doon nyo siya i-run. Okay? So instead of typing this isa-isa sa MATLAB command, pressing enter every time matatapos kayo, okay? Just simply type this into an editor. Okay? And then i-run nyo na lang siya as 1. Okay? So dito, ang maganda pa dito is that naka-code cells to. So I can actually just simply run a code cell. So ibig sabihin, pwedeng ito lang yung i-run ko. Hindi ko i-run yung buong programa, i-run ko lang ito lang. O kaya i-run ko lang itong part na to. Okay? So that is the code cell. Para makapag-initiate kayo ng code cell, ito, double percent para makapag-initiate kayo ng code cell. Okay? So ito, another code cell ito. Okay? So sige. We'll have xn equals u delta 0, negative 20, 20. So which means this is a unit sample sequence for between negative 20, okay, and positive 20. Okay, then natin siya, lagyan natin ng semicolon. And i-plot natin siya, graph the unit sample sequence system and x field title is unit sample sequence x label sample m, tapos y label signal values x, then grid on. And ito, copyhin ko na lang ito, baka ito. Control C, Control V. So, ayan. So this is now using yung function ninyo, okay, in order to generate a unit sample sequence. So pag nirun natin yan, again, i-run ko lang itong part na to, that's Control Enter. Okay? So lalabas ito. Yan. So you see, you can generate the same thing, okay, using two techniques. Number one is using the zeros function and by concatenation. Okay? Number two is this one. Okay? So ang maganda dito is madali yung shifted version. Okay? For example, gusto niyo ng gusto niyo isulat yung lagyan natin dito, i-save natin siya dito para. So meron kang delta n dito for n between negative 20 to positive 20. Ito yung ating edit, copy figure. Okay. Tapos paste natin siya dito. Ay. Copy figure. Yan. Okay. So, next natin, sabi natin gusto nyong i-generate yung delta n o delta n plus sabi natin 10. Okay? Delta n plus 10 for negative 20 to positive 20. Okay? Kung dito nyo gagawin yun, medyo mahaba-habang proseso. Kasi magbibilang pa kayo kung ilang zeros eh. For example, kung negative kung delta n plus 10 ito, ibig sabihin, this is 1 for n equal to negative 10. Okay, and 0 elsewhere. Okay, so ibig sabihin, dapat, ito, yung n2 nyo dito, dapat maging negative 10 to. Okay? Then ito maging negative 11. Tama ba? Kasi magiging 0 siya from negative 10 to negative 11. Tapos pagdating ng negative 10, magiging 1 siya. Okay? Tapos pagdating ng negative 9 hanggang positive 20, magiging, magiging 0 ulit siya. Okay? Naintindihan ba? So, tingnan nyo yung lalabas. This is control enter. So, you have here a signal. Okay? That is 1. Okay? That is 1 for n equals negative 10 and 0 siya elsewhere. So, ang tawag natin dito is an advanced version. Okay? This is an advanced version of your delta n. Okay, so lagay natin siya dito sa So, lagay natin siya dito. Yan. So, essentially, yan yung delta n plus 10 ninyo. Ito. Okay? So, yung again, by definition, yung delta n plus 10 natin is 1 siya for n equals negative 10 and 0 siya for n not equal to negative 10. Okay? Kung nagtataka kayo, bakit plus 10 tapos negative 10 to? Tandaan nyo na ang shifted version, okay? Shifted version of delta n is delta n minus k. So, essentially, yung delta n plus 10 is actually equal to delta n minus negative 10. Kaya yung shift dito, which is yung k, is negative 10. Naintindihan? Okay. So, ganun din siya dito. Dito naman, ang gagawin natin dito is papalitan natin tong number na to. Instead na 0, gagawin natin negative 10 yan. So that you can produce a unit sample sequence that is 1 for negative 10 and 0 for n not equal to negative 10. Okay? So again, run ko tong code cell na to by pressing Control Enter. Ito yung results niya. Yan. Same thing pa rin, di ba? Okay, naintindihan ba yun? Okay, so either you do this part or you do this part. May konting pagkakaiba lang on how you execute them. Okay. But still you can generate your unit delta sequence or unit sample sequence using those two methods. Okay? So, ayun. Isa pa, maglagay pa tayo sa example. So, tawag natin dito is advanced. Okay? This is an advanced sample sequence. Okay? Actually, i-explain ko to in a later lesson. Okay? Pero sa context na pinag-uusapan natin, when you say the shift is advanced, okay, it means that you are shifting the signal to the left. Okay? If you shift the signal to the left, kung originally nandito yung 1, tapos shift nyo siya sa left, that is called an advanced shifting that shift is called an advance. Okay? Maliwanag? So if the shift is done, or if the signal is shifted to the left, okay, the resulting signal is an advanced version, okay, of the base signal. This is the base signal. Okay, yan yung base signal. Ngayon, pag shift nyo yung sample na yan to the right, to the left, okay, the resulting shifted signal is an advanced version of the base version. Okay? So, consequently, pagka yung signal ay shift natin to the right, okay, that signal naman, that version of the signal naman is a delayed version of the signal. So, an example of that is delta n minus 7 for n between negative 20 to positive 20. Okay? So, kapag rinaf natin ito, okay, essentially, ang value nitong signal nito, wala na. Saglit lang. Natatagal lang siya mag-sync. Ayan. So, kung meron kang kung meron kang delta n minus 7, okay, essentially, the value of this is 1 when n is equal to positive 7 and 0 for n not equal to positive 7. Okay, sa MATLAB, ganito natin siya gagawin. So, kung positive 7 siya mag-1, so dapat positive 7 ito. Okay? So, yung numbers before that, that's negative 20 up to positive 6, dapat 0 siya. Okay? And then, yung numbers after nito, that is from 8 to 20, dapat 1 siya. Naintindihan? So, pag ito, ang graph natin, ito yung lalabas. Yan. So, yung nababas signal, that has a value of 1 for n equals 7. Okay, ito. Yan. Value niya ay 1 for n equals 7. So, lagyan natin siya ngayon dun sa ating So, yan. Now, again, as you can see here, okay, as you can see here, this is delta n minus 7, which is 1 for n equals 7 and 0 for n not equal to 7. And again, this is called a delayed, okay, a delayed sample sequence. And again, sa context ng pinag-uusapan natin, when you say a sequence is delayed, it means that the ano yung nilagay ko dito? Para parallel siya. Shift sila. When you say the shift is delayed, okay, it means that you shift the signal to the right. Okay? Naintindihan ba? Okay, so that's your unit sample sequence. Okay. Now, the next elementary discrete time signal that we will deal with is the unit step sequence. Okay? The unit step sequence. So, essentially, pareho lang ito ng idea with that of the I mean yung generation niya, okay? You can actually understand kung paano yung pag-generate nito by actually understanding kung paano yung nakuha yung kanina. Okay? So, pero una, i-define muna natin what is a unit step sequence. So, this is this is represented by the variable u, okay? Which is defined as 1 for n greater than or equal to 0 and 0 siya for n less than 0. So, ibig sabihin for positive n, okay, yung u of n nyo is equal to 1. But for negative n, this includes 0 ha. For 0 and positive n, your u of n equals 1. And for negative n, okay, for negative n, your u of n is 0. Okay. Ito yung counterpart ng delta t. I mean u of t pala. Yung u of t, yung step signal ng analog. Sa analog, ang tawag sa kanya u of t. Okay? Sa discrete time signal, ang tawag sa kanya u of n. Pero pareho siyang tawag na step signal. Okay? Yung kanina, yung delta n, meron tong may katapat din yan na delta t sa analog. Okay? Tawag nyo dyan impulse signal. Okay? Sa analog. Okay? Medyo iba lang yung definition nito with that of the Okay? Kasi ito 1 kasi yung value niya sa discrete time signal. Okay? Pero ito kasi sa digital signal, walang eksaktong value siya. Okay? Basta ang alam lang natin, yung integral ng delta t from dt from from negative infinity up to positive infinity is equal to 1. Yan lang yung alam natin. Pero wala siyang ganitong eksaktong definition. Okay? So it is thought of na it is thought of na close to n equals 0. Close to t equals 0. Okay, close to t equals 0. Ang value ng delta t nyo is approaching infinity. Okay, yan yung definition sa analog. Okay? Pero sa discrete time signal, 1 lang naman siya when n is equal to 0. And 0 siya when n is not equal to 0. So, yun. Okay? So yung inaaral natin ngayon for the first two parts are actually mga discrete time counterparts ng mga analog signals na inaral natin sa other courses. Okay, so ayun. Now, ang kanyang hindi to delayed shifted to. Dami na palang mali nitong manual na to. Okay, matagal ko na kasi hindi na-update to parang last year pa yata huling na-update to. So, medyo marami na pala siyang marami na ako nakikitang mali sa kanya ngayon. Okay, this is why is shifted version un minus k is this one. So, ibig sabihin, magsisimula yung sequence ng 1 after the value of k. So, parang ang lalabas niyan, kung ito titingnan nyo, that is simply, pag negative yung n, 0 siya. Okay. Pero once na n becomes 0, 1 na siya. So, siguro, dun yung maintindihan yung term na step. Okay? Kasi mag-shift yung value niya from 0 to 1. And it becomes a constant 1 after that. Okay? Naintindihan ba yan? Okay. So yung shifted version niya is simply changing kung kailan magsisimula itong 1. Okay, kailan magsisimula yung sequence of 1 na to. Okay? So kapag ito, pag yung k nyo is a negative number, then it is shifted to the left. So therefore, ma-advance yung signal niyo. Okay? Or ma-advance yung unit step sequence niyo. Okay? Pero kapag yung k nyo is positive, mag-shift to actually to the right. So, ma-delay yung signal niyo. Okay? So for example, you can use the MATLAB function once, okay, in order to generate yung sequence of ones na kailangan niyo for this signal. Okay? So, for example, to generate a row vector of a unit step function or unit step sequence for for n between -5 to +5, we can use the command zeros 1, 5 and then ones 1, 6. Mangyayari kasi niyan is kailangan nyo, kung -5 to +5 yan, from -5 hanggang -1, kailangan nyo yung x nyo 0. Okay? Pero from 0 up to +5, kailangan nyo mag-generate ng x na puro 1. Okay? So that is why ito is generated so that would become the signal values for n equals -5 to -1. Okay? Ito naman are the signal values that you need in order for you to define the signal values from n equals 0 up to 5. So itong command na to becomes this. Okay? Now, in the same manner, pwede nyo gamitin yung logical test na to in order for you to generate, okay, in order for you to generate yung yung kailangan nyo ring unit step sequence. Okay, for example, katulad ng ginawa natin kanina, command window, ayan. I-clear muna natin ito, CLC. For example, for n equals -6, -8, for example, to +8. -8 to +8. Then, yung x nyo can be defined as n greater than equal to 0. Okay, so this is basically u step n. Yan yung un natin. Okay, for n between -8 to +8. So ito yung lalabas sa kanya. So from -8, 7, -7, -6, -5, -4, -3, -2, -1, 0 yung value ng signal natin. And then from 0, 1, 2, 3, 4, 5, 6, 7, 8, yung value niya is 1. Okay? Naintindihan? Okay, kaya lang again, logical array siya. So para maiwasan natin magka-problema later on with the computations, instead of using a logical array, convert or i-typecast na natin siya as a double precision number. Ayan. So lalabas ngayon, yung x nyo ngayon is a double precision number na. Okay, so halos pareho lang din ng kaninang para sa delta n. Delta n. Okay? So, let's try working so ganun pala. Meron din ako sinuggest na function form nung inyong unit step sequence so that later on baka magamit niyo siya. Okay? So, ayan. Nandito siya ngayon, available naman siya dito. Naisulat ko na siya before. Saan na yun? Ayun, unit step .n. Function file siya. Okay. So, let's do yung procedure which is the procedure on generation of unit step sequence. Okay? So, procedure generation of unit step sequence. Step 1. Ito siya, ito yung step 1. Okay? So you have clear all, close all. Samahan nyo ng CLC to. So, N1. Wait lang. Mali pala yung location mo. Yan. Ito open all, close all. So N1 is negative 20 to negative 1. Okay, in that case, ang value nyo ng x nyo for that is puro 0. So you have zeros, 1, length, N1. Okay, so ganito yun, no? Kaya natin ginagamit itong argument na to in order for you to itong function na to para ma-generate nyo itong zeros na to. So that whatever the length of N1 is, kung gaano karami yung elements nito, okay, yun yung ipapalit niya dito. So that kapag pinalitan nyo to, hindi nyo na kailangan problemahin kung ano yung ilalagay dito. Kasi siya na yung magko-compute kung ano yung length ng N1. Okay? So, accordingly, pag ito binago nyo, mag-a-adjust din to. Okay? So, programmatic yung approach natin in determining the length of your zeros na kailangan natin. Which dapat nyong matutunan na as a skill whenever you are doing your codes. Kasi hindi naman pwedeng lahat mano-manong dinedetermine ninyo eh. Okay? Let the tool determine some of the things for you. And para automated din yung ibang bagay nung ginagawa ninyo. Okay? Hindi yun laging mano-mano kayong nagbibilang, for example. Okay? So, next, you have N2 equals from 0 to 20. Okay? X2 equals ones naman siya. Kasi from 0 hanggang 20, okay, 1 yung value ng signal natin. So, this is ones, length, N2. Yan. So, yan. Then, i-concatenate natin siya. So, N as N1, okay, and N2, okay. Then, ang X natin is X1, and then X2. Okay. Then, graph natin siya. Actually, pwedeng copyahin ko na ito. An advantage of using the editor. Okay. An advantage of using the editor kapag kayo, gumagawa kayo ng mga ganitong activities. Kasi may mga, mapapansin nyo rin na may mga segment of codes ako na ginagamit pa ulit-ulit. Okay. So, instead of actually retyping the everything, kapag ginamit nyo yung editor, pwede nyo i-copy and paste na lang yung mga segments na yun na inuulit natin. Okay? So, you have here unit step sequence. Okay? So, this unit step sequence. Okay. So, I think everything else is pareho na. Okay? Naintindihan ba to? Okay, so running this code cell, ito, i-run na natin itong code cell na to. Okay, produces this graph. And, by the way, hindi, graph is just one of the, lilinawin ko lang to whenever you are trying to generate, whenever you are trying to generate signals, the graph is just used to visually look at the signal. Okay? But the important output of your code whenever you are generating signals is yung sequence itself. Okay? Ito, yung variable na to, yan yung importanteng parte nung yan yung importanteng output ng sequence niyo. Kasi yan yung gagamitin niyo for next computations. Okay? Ginagamit lang natin yung graph in order for you to visualize ano yung itsura ng signal natin. Okay? But this is where your signal is. Okay? Diyan nakalagay yung signal niyo. Okay? Dun sa output variable. Or yung variable na naglalaman ng values ng signal niyo. Okay? So therefore, this is the most important output. Okay? of your code that would generate a signal. If you're generating a signal, ang objective ninyo is to be able to generate a variable that would contain your signal or would contain the values of your signal. Maliwanag ba? So in essence hindi yung graph ang signal niyo. This is not your signal. Your signal is this variable. Okay? This is your signal, not this graph. Okay? So I hope that is clear. Kasi sa totoo lang, hindi niyo naman ma-generate itong graph na to kung wala rin kayo nito eh. Okay? Kung wala kayo nitong x na to, which is computed. Ito kasi yun, ito yung pagko-compute nyo ng x. Okay? And importante rin ito, yung pag-a-assign ng index dun sa x. Okay? So, itong dalawang to ang importanteng ma-produce nyo in a code that would produce or that would generate a signal. Yung x, which is the value of your signal, or the vector that would contain the value of your signal, and yung n, which contains the time index vector for your x. Okay? So, tandaan nyo na hindi nyo ma-generate itong graph pag wala yung dalawang yun. Kaya ito yung importanteng parte talaga ng ng code niyo, how to generate those two. Okay, so this is not your signal. This is not your signal. This graph is not your signal. This is your signal. Itong x at saka itong n. Okay, is that clear? So, ito na nga. Ito na yung visual ng ating unit step sequence. Okay? So, lagyan na siya dito. So, this is your delta M. Ay, sorry, hindi pa siya delta. U of N na pala siya. U of N na siya for N between negative 20 to positive 20. So again, ang value nito is U of N is equal to 1 for N greater than or equal to 0 and 0 siya for N less than 0. So lagay natin yung value ngayon dito. Okay. Lagay natin siya dito. Ayan. So, that's your delta M. Okay? Another approach, okay, that can be used to generate your unit step sequence is this. Yung second step ng procedure na yan. Okay, which is ito. Ito yung mga commands. So, step 2. Let's have clear all, close all. CNC. You have there x n equals u step 0 negative 20 to 20. Okay, so again that line of the requires the u step function, which means kailangan nakikita nung MATLAB ninyo ito yung u step function na yan. Okay? Is that clear? Okay. So, continuing. You have ayun, mag-graph na pala siya. So, uulitin ko na lang ito. Again, perks of using the editor. Okay? So, again, running this code cell by pressing Ctrl-Enter gives you the following graph. Yan. So, pareho lang, di ba? We can have that one. Okay? Then, just talking about the, yung delayed at saka yung advanced version niyo. Let's say, for example, you can have, u of delta n plus, sabi natin 6. Okay? We should be equal to 1 when n is greater than or equal to negative 6. Okay? And 0 siya for n less than negative 6. Okay? So, ang itsura niyan is ito. If you'll be using the step 1 code, okay, i-take note lang natin na magiging 0 siya for negative 20 hanggang negative 7. Okay, hanggang negative 7. Kasi pagdating ng negative 6, pataas, ang value na niya 1. Okay, naintindihan ba yun? Okay, so running this segment of the code, pressing Control Enter would give you this one. So makita nyo ngayon, magsisimula yung sequence of 1s. Okay, magsisimula yung sequence of 1 at negative 6. So from negative 6 onwards, okay, for n greater than or equal to negative 6, yung value ng signal nyo na ngayon is 1. Okay? Dito naman, sa step 2 code nito, that one is simply achieved by changing this argument to negative 6. Okay? So again, running that one. Control Enter. So you'll have the same graph. Okay? Identical graph for the previous step. So, naintindihan ba yan? Okay, so tulad nung ginawa, sinabi natin about kanina, okay, since your signal is being shifted to the left, okay, this is an advanced version, okay, of u of n. Okay, that's an advanced version of u of n. Okay, again, advanced because you're shifting the signal to the left. Okay, while if we have u of n, say, for example, minus 12, okay, which is now 1 for n greater than or equal to 12. Okay, and 0 siya for n less than 12. Okay? We can generate this signal by dito sa unang step, okay, we take note na 0 siya, okay, 0 siya from negative 20 hanggang negative 11. Positive 11. Kasi 12 lang siya magsisimula na maging 1. So from negative 20 hanggang positive 11, 0 yung value ng signal niyo. So while from 12, positive 12 hanggang positive 20, ang value ng signal niyo is 1. Naintindihan? Okay, so pag renap natin ngayon to, you'll have this. Okay, so magsisimula ngayon yung first one ninyo when n is equal to positive 12. Okay, kung dito nyo naman siya gagawin, you simply change this to 12. Okay, which will give you the following signal. So, ganun din. Okay? So, ayan. So, copy natin siya dito. Then paste. Ayan. Okay? Now, since this signal is being shifted to the right, okay, this is called a delayed. Saglit lang. This is called a delayed version of U of n. Okay? So, maliwanag ba to? Yung tatlo na yan? Okay. So, so I have already demonstrated yung first two na signals that you need to generate here. Okay? I think I can leave the rest up to you. Okay? So, tingnan nyo, aralin nyo mabuti. Paano naman i-generate, for example, yung exponential signal. Okay? So, dito, meron tayong sinasuggest na sa procedure natin, meron tayong sinasuggest na function. Okay? Meron tayong sinasuggest na function in order for you to generate an exponential signal. Okay? Pero meron naman siyang parang mano-mano. Or meron naman siyang parang kumbaga hindi mo naman kailangan mag-generate using the function itself. Okay? Also, you would be noticing that some of these exponential signals are being multiplied by a unit step signal. Katulad nito. Tingnan niyo itong expression na to. Okay? Kung titingnan niyo itong expression na to na mabuti. Yan. Sorry. Kung titingnan niyo yung expression na yun na mabuti, this is actually an expression, okay, used to generate a u of n minus k. Tingnan niyo mabuti yung expression na yan dun sa function sa taas. That is used to generate u of n minus k. Okay? Essentially, yung expression na yan is an expression used to generate u of n minus k. Okay? Tapos itong expression na to, okay, is used to generate an exponential signal a raised to n minus k. So essentially, kung titingnan niyo mabuti itong buong expression, this is simply yung exponential nyo multiplied sa step signal niyo. So essentially, that signal is a raised to n minus k multiplied to u of n minus k, which is what we will do sometimes. Okay? Especially kapag gusto natin na yung ating exponential signal is 0 for a certain value of n. Okay? Kung gusto natin na yung exponential signal natin is 0 for certain values or for certain set of values of n, then ganito yung gagawin natin. Okay, by the way ang dami talagang mali nitong manual na to. Okay. Paki-correct ito itong part na to. Gawin niyo tong x equals double. Essentially, lagyan niyo na siya ng double. Tapos ito, yung expression na yan. Naintindihan ba? Hindi ko siya mapagkakasya eh. A dot raised to n minus k. Yan. So, ito, tapos yan. Yan. So, palitan nyo siya ng expression na yan. Okay? So, kasi yun nga, ang problema kasi, magiging logical array ito. And although, once na i-multiply itong logical array ng MATLAB dun sa ito, mata-typecast na siya automatic as a double. Unahan nyo na siya. Unahan nyo na siya na ang maging, na siya na yung mag-typecast. Okay? O kaya, wait pala. Instead na ganyan, ito pala. Sorry. Mali pala yung ito. Lagay nyo siya dito. Yan. So, i-typecast nyo na to as a double precision number bago nyo siya i-multiply dun sa exponential sequence niyo. Okay. And take note na yung function niyo has 4 arguments now. A is for the base of the exponential. Okay. K is the delay, is the shift. K is the shift. Okay. Tapos yung N1 is the lower end of time index vector, while N2 is the upper end of the time index vector. Okay? Maliwanag? So, I'd leave the rest of the activities up to you. Okay? Try to figure out yung mga yung ilan sa mga nitty-gritty details of that by inspecting the commands that you are using and trying out some values para mas maintindihan nyo kung paano paano nakaka-apekto yung mga values na nilalagay nyo dun sa signal ninyo. Okay? So, ayun, yun lang. So I think we can finish the synchronous session at this point. And I leave you to work on the activity. But still, if you have questions regarding this activity, i-raise nyo lang siya sa akin so that we can have a discussion about this activity. Okay? Pero so far, may questions ba kayo? May questions pa tayo so far? Okay, so mukhang wala naman. So let's dismiss the synchronous session for today. Okay, and I'll see you next week if meron tayong synchronous session. Okay, so titignan ko kasi if yung activity to nyo kasi ina-transfer ko na lang siya dito sa notebook. So kaya lang mukhang since marami akong naspatan na error dito sa activity 1 ninyo. Mukhang kailangan ko ring tingnan yung activity 2 ninyo kasi baka mamaya marami na rin palang errors. Okay, so from last year kasi na hinawakan ko to. Term 3 ko huling hinawakan itong course na to. So baka marami na tayong naisip na pwedeng i-correct dun sa natin sa ating manual. So titingnan ko muna siya. So if I would be able to do that, then probably baka may assign ko na rin yung activity 2 ninyo before next week. So yun yung pag-uusapan natin next week kung sakasakali. Okay? So sige, we can dismiss the meeting now for today. Thank you for attending today's meeting. I'll see you next week. Okay? If you have questions or concerns, wag mahihiyang magtanong. Okay? Thank you for attending. Okay. Sige, tara na.
Thank you po.
Thank you po.
Ano lang tayo ha? Palive na lang ng meeting pagkatapos. Okay. Thank you.